Dear students, welcome back. In this video, we will discuss about creating multiple threads, and then we will also discuss two important methods in thread class. One is alive and second is join method. These two are very important methods and they help us a lot in implementing the concept of multi-threading. First, let us create multiple threads. I continue with the example we created in the previous video. You can see I had this child class that extends from thread class in its constructor. Say for example, this time rather than assigning a static name, we are going to receive name from the creator. So here uh, I'm passing this name rather than always a constant name, right? And then we create we just display the information, right? In its run method, we are doing same thing for sleeping for half a second and then displaying the message, right? uh, and then you know I should also display here the message like I maybe before I display the name of this thread, which can be this, right? I print this and then plus this, right? Maybe a space and then plus, right? So we say child thread, here will be the name of the thread and then the space and then current value of I, right? Getting interrupt exception, and then we say child thread ends plus I just display the message this, right? So this is my child thread. I'm going to compile it. Java C child thread dot Java compile, and then going into the main file, child thread demo. Here rather than creating just one thread, now I will be creating three threads. Maybe I can call this one as one, passing it name one, right? And then copying it twice, control V, right? So that was one, this one is two, this one is three, right? So one, this is two, and this is three, right? So now we start one. You know that its run method will start and it immediately goes to sleep. So CPU will have some time. So we have 2 dot start, then 2 will start, right? And then 3 dot start. So the 3 will start, right? And then when all these start, they actually voluntarily go to sleep, right? They voluntarily go to sleep. It means time will be given to the main thread. So when time is given to the main thread, it again goes for the sleep for 1 second, and then it displays, and when it continues its execution, all these threads are given time interchangeably. One will start, two will start, three will start. All of them, if they go to sleep, main will get the turn. It goes to the sleep. It means that the time, by that time, one should have woke up because it went for the sleep for half a second. So when this goes to the sleep at that time, probably one will get the chance, then two will get the chance, then three will get the chance. So all these threads will continue and trying to complete their task, which is actually given inside the run method of these three threads, right? In each of these three cases, we are differentiating them with their name 1, 2, 3. So obviously when they are displaying a message, we'll know that which thread has actually displayed the message, right? So I save this thread class demo, Java C thread class demo.java, compile. It has been compiled, right? Now I say Java thread class demo. Okay, you can see here. You have to interpret it, you have to interpret it, you have to understand it. You can see here child thread 1, then 2, then 3. They were all created, they displayed the message, right? And then child thread 2 got the chance, it displays 0, and then 1 got the chance, displays 0, and then 3 got the chance, displays 0, right? It's all random because one might have got chance before the other, right? And then main thread displays 0, and then 2, 1, 3, all of them print 1, and then 2 prints 2, 1 prints 2, 3 prints 2, and then main gets a chance because main is quite lazy, this sleeps longer than others, right? So you can see all these threads are running concurrently, each one of them is trying to complete its execution. We just push them in start state by calling a start method, but when CPU gives time to them, it's not fully in our control at the moment, right? All of them are in the start state. When CPU is going to give them time, we really do not have control with the so far knowledge that we have gained. We'll obviously gain more control, but for the time being we just say we are pushing them in the start state, and when they are going to run, it depends on the CPU's decision, the decision which actually the scheduler is taking, right? So you can see all of them are running in concurrent. One thing is of importance, all of them are in the main group. You can see this is the name of the group to which all these threads are belonging to, right? Though their names are different, but their group is same. And you can see all of them have got default priority, which is 5. It means that no thread is having more priority than other. It is just that some of the threads are sleeping more than other, so obviously those which sleep less, they will complete their execution first, and main, because it sleeps for 1 second every time, so this actually ends its execution in the end, right? Okay, so this is how we can create multiple threads and run them concurrently. Now we see two important methods. One is alive and second is join. Now in all these examples which we have seen so far, you saw that we deliberately tried that main thread should sleep for 1000 milliseconds because we wanted main thread should end after all other threads have ended, right? Because this is a kind of scheduler, this is a kind of traffic police, because it created these 3 threads, so this should be ending after all these threads have died, right? In order to ensure, we actually made this arrangement, and this arrangement is, we said you will have to sleep for longer, right? So you can see this sleeps for 1000 milliseconds and other sleep for 500 milliseconds. So we are hopeful that this main thread will end its execution after all other threads have ended their execution. Obviously this is not the only solution. We have got these 2 methods at our support because we discussed in the very first video of multi-threading that inter-thread communication by using messaging is quite strong in Java, and obviously that inter-thread communication is handled by using different method calls, right? So the 2 methods which are important, one is alive and second one is join. This is alive method returns true if a thread on which it is called, if that thread is alive. If that thread has died, then this will return false, right? Let's use it first. You can see here we are starting all of them. If I say, for example, write here system dot out dot println, I say thread 1 is alive, right? Let's check if it is true or false. So I can write here 1 dot is alive. We call this method is alive on the reference of the thread, right? So this method is actually coming from the base class, the thread class, and we are calling method is alive. If it is alive, it will return true, otherwise it will return false. Obviously, because we are calling it here, Control C, Control V, Control V, Control V. So we are checking if thread 1 is alive, thread 2 is alive, and thread 3 is alive, right? So 1, 2, and then 3. right? So obviously here all of them would be alive. Let's check it. Let's check it. Okay, CLS Java C. Okay, Java C, Java thread class demo. You can see thread 1 is alive, thread 2 is alive. Huh? I mean, this gives us information that if thread is alive or not. So you can see here thread 1 is alive, thread 2 is alive, and thread 3 is alive. Right, all of them are returning true. Now let us call this when these thread actually die. Right, control C. We know that when we reach here, when main method is ended, these should have died by that time. These should have died by that time. So we will see that. So after we print this information, then we are writing here to check if threads are alive or not. So this should return false at that stage. You can see here, okay, alive, it's true here, but then it returns false when main ends. Why not? I said thread, where is this? Try. What am I doing? Thread class demo. Okay, maybe I do it again. CLS Java C child Java C thread class demo. Okay, Java thread class demo. Okay, it should display at the end that thread are not alive. Right, so you can see here thread 1 is alive, no. Thread 2 is alive, no. Thread 3 is alive, no. Right, so you can see on a thread we can call this isAlive method to check if a thread is alive or dead. Right, now let us see another thing. Here we were sleeping for 1000 milliseconds because we wanted to make sure that main should end after all other threads have ended. For example, if I make it this, then you know that main will end even before other 3 threads have ended. Right, in that case obviously even when main exits, these still will be alive. Let's check it. I can come here, I say system dot out dot println, I say main ends. So main ends here, but even after main ends, other threads should still be alive because this sleeps lesser now than other 3 threads. So obviously the amount of time that other threads are sleeping is a lot higher than the amount of time main is sleeping. So certainly execution of main will end before other 3 threads have ended. So in this case obviously main will end. In this case main will end even before these 3 other threads have ended. So this statement there should be returning as true. Obviously this does not look very good that main created other 3 threads, but then it died before they ended their execution. In many cases we would like that the thread which created others should be the last to end, but here that won't be the case. We'll see how to fix this problem, but for the time being let's see this issue. Java C Java thread class demo. You can see here main ends. Main ends they are still alive. And then main ends, and all these threads are still running. And obviously it's a kind of traffic police has died, and this traffic is now completely gone wild. No one is there to control them. So obviously that does not make sense. That is the reason why they say there should be a way to ensure that main should wait others to end first, and that we can do by using uh, the join method, right? And we can call the join method. You can see here we have another method which is join. It throws interrupted exception. Both of them are final, by the way, and when methods are final we cannot override them. So we cannot override them, but we can use them, right? So we say now rather than sleeping for longer interval, we are going to call join inside the main method. When you call join inside the main method, it means that now main will end other threads to end before main can end. So what I can do, I can write here 1 dot join, right, and then 2 dot join, and then 3 dot join, right. Now when you write a join statement on a thread, it means that the control should not be given back to this thread that this method has been called from unless this thread ends, right? It means that now main says I will wait until 1 ends, right? Similarly, it says I will wait until 2 ends, and then it says I will wait until 3 ends. And obviously this throws interrupted exception, so it has to be kept inside the try block, right? So I already have try block, so let me keep it here. Even if it ends its execution after the for loop, it is going to join on these 3 threads. It is going to join on these 3 threads. It means that now main will not end its execution before 1, 2 and 3 are ending their execution, right? Let's check it now. Java C, okay, CLS Java, okay. Now you can see here main should not end. Why main has ended? I said it. Save, okay. 1 dot join, 2 dot join, 3 dot join. Okay, we are waiting. Main thread, it should wait. Why? Oh yeah, they are still alive. They are still alive. Main. Let's double check it. CLS Java C thread Java C child. That is the name. Thread class demo. Thread class demo. Okay. Java thread class demo, right? So you can see now main is really joining on them. Only then it comes here. So you can see now this is delayed. Also these 3 statements are delayed. Otherwise these were statements here and the value was true. But now because we have said that main will wait until 1 ends, until 2 ends and until 3 ends. It means that main thread says I will wait until 1 end, then 2 end and then 3 end. Then it moves further. And obviously when it reaches here, all these 3 have already ended their execution. So here it will obviously return false. So you can see these values are false here, and then main ends. And that was our objective. We want that this main thread, which is like a traffic police, it should end only when all other threads have ended. So in this case you can see this join method is helping us a lot. You will encounter situation where you would like that current thread should stop its execution until another thread completes execution. Maybe you are a consumer, right? You are going to consume some character from a file, and you say that there is a writer. So you say writer should finish writing first, only then I will start consuming. So in that case you can join on that thread. When I say you will join on that thread, it means that voluntarily you say I relinquish the control and I give control to the writer. so that writer can complete its write operation, and when that write operation completes, only then I will resume my execution. Right, so join method is actually an effort to suspend the execution for the time being until another thread completes its execution. So here main thread said, well, I had to display 1 to 10, what I've already done, but I'm not going anywhere. I'm not going to kill myself before you end their work, 2 you end your work, and 3 you end your work. When all of them complete their execution, then main continued its remaining work, which is to display if all of them are alive or dead, displaying this information and then displaying this message. Right, I hope you got the understanding of alive method and join method. I stop this video here, and when I come back, we'll be playing with the more methods of thread class. Thank you very much. By the way, I have also decided that in the next video I will be using any IDE, maybe IntelliJ or NetBeans, but I really do not recommend you people to switch to IDE. More you work with Notepad and command line, better will be your programming skills. I am doing it only because I want to make my videos shorter. I want to avoid this shifting time, so that a video of 20-25 minutes should be 15 to 16 minutes. Right, so this will help me reducing my video time. There is no other reason why I should be shifting to IDEs. Thank you very much.